Alright, so this is question 7 of the homework. So for part A is asking us what's the coordinates of the particle at t equals 5 seconds. There's a few ways to do this, but essentially what you need to do is calculate the area under the curve from 0 to 5. And the way I've done it is that every single square is equal to 4 meters and every single triangle is half of that, 2 meters. Why 4 meters? Because VS we're given is 8. So, and since there's 2 squares for each VS, that means each square is 4. So if we were to count, there's 1, 2, 3, 4, 5, 6 squares from 0 to 5, and 3 triangles. 6 times 4 is 24. 3 times 2 is 6. Add them together, 30 meters. 30 meters. For B, we're being asked about what's the velocity of the particle at 5 seconds. So for this one, we can just directly take it off the graph, which is right here. It's exactly half of Vs, which happens to be 4 meters per second. So the velocity at 5 seconds is 4 meters per second. For C, we're being asked about the acceleration of the slope. We're being asked acceleration at t equals 5 seconds, which is just the slope. There's a few ways to do it. The way it's most intuitive is just the change of speed formula. So you just take the speed at 4 and the speed at 6, minus them together, and then divide it by the change in time, which is -2 seconds. If you were to do that, it would be right here. You get -4 meters per second squared. So, for D, they're asking you about the average velocity between the particles between t equals 1 and t equals 5. Average velocity is just distance over time. So to find the distance, you can use the same squares and triangle or any other way to find the area under it. You'll find that the distance is 28 meters and the time that passed is just 4 seconds. So if you divide 28 meters by 4 seconds, you get 7 meters per second. And for E, it's the easiest one. They're asking us for the average acceleration of the particle from t equals 1 t equals 5. Acceleration is just the slope in velocity in a velocity chart, and the slope between t equals 1 t equals 5. Imagine that there's a line here, it would just be 0. So the answer is 0.